So in this particular case, so you're going to take f of a, which is 3a, and then you're going to divide it by 4a minus 3. All right. Now they said to plug in a negative 2b where your input value is. So that's going to be 3 times negative 2b, and then be 4 times negative 2b minus 3. Okay. So they wanted you to set it up. I mean, you can set it up first with the original input value, and then this is the input value they want you to put in. Now, if you evaluate this and clean up as far as you can, that's negative 6b, and then negative 8b minus 3. Guys, honestly, that's about as far as you can take that. Okay, that's about as far as you can go with that. Now on this one, since you're evaluating with a number, there's a couple different ways you can go about doing it. You can plug in a number and get get a numerical value for both of these, and then just add them together like it says, or you can just add your expressions together and then plug the input in. It's really up to you what you want to do. Okay, so n minus 3 plus 2n minus 1. All right, so that's G plus F. Okay. Now I would combine my like terms. That's 3n minus 4. Now, after you get your terms combined, you're going to plug in this numerical value here where you see your input value variable here. So it's going to be 3 times 9 minus 4. So we added G plus F together, combine like terms, and got this. All right. And then where the input value is, a variable, we inputted this value there, which was a 9. And 3 times 9 is 27, minus 4 is 23. That's your answer. So guys, if you get a numerical value, if you're given a numerical value to plug in, you should get a numerical value at the end. All right. All right. Now, guys, this one state if the given functions are inverses. There's a couple different ways you can do this. If it was me, what I would do is you could take the inverse of one of them and see if it matches the other one. You could do that and just see if they match. Or you could just plug a number in. Because remember, the rule of an inverse is if you have an original function f and you plug in a value a, whatever that a value can be any number, okay? And you get an output value, and we're going to call that number b, okay? B is just a number you get out after you plug an a in. Then if it's truly an inverse, if you plug in the output value of your original as an input of your inverse, you will get your original input back. Okay. So basically, what happens, guys? The numbers just swap places, pretty much. So that being said, and I always try to use the smallest numbers possible. If I do f of 1, then this is the top one. Negative 5 over 6. All right. Now, so if I take, now guys, I just chose 1. I chose 1 because it's small and it's easier to work with. Okay. Now, if I take that number, or if I take that and plug it in on my calculator, so and then I'm going to put in that 1 there. All right, so I'm going to evaluate that and see what I get. Okay, now that's my output value. Okay, so we'll write that down. So my output value here, so I plugged in a f of 1 and got an output value of -3/2. Okay, so now this was my A value, that was my B value. Okay, going by the rule up here, this is my A, this is my B. Okay, so now what it's saying is I should be able to put this output value into the inverse, and it should give me back the number 1. Okay, so now let's so going down to we'll let G be our inverse here. So it's going to be negative. Then I'm going to all right, so I plug that in. So -6 times 5 times -3/2 minus 4/5. All right. Now, notice, guys, when I plug that in, I should have had. Oh, shit. All right, so when I plug that in, let me make sure that don't make a difference. No, it doesn't. It takes it out anyway. I don't know why. Okay, so guys, notice when I plug that input value in. So what I did was this: -6/5. I plugged in at -3/2 minus 4/5, and I got a 1 back out. Right now, so guys, what I did was I did my inverse, plugged in -3/2. Now, guys, looking at this right here, does that prove that those two are inverses? It does, because if you think about it, guys, our A here was 1. We chose, now, guys, there was no rhyme or reason why I chose 1. Well, the reason I chose 1 is because 1 is a small number and it's easy to work with. All right. I plugged in a 1, and my output value after I plugged it in f of x was -3/2. Okay. Well, I took that output value and put it in my inverse. We'll call this my inverse here. Okay. I plugged that in, and it gave me my original output back. So if that happens, then that is an inverse. So that would be an inverse. And guys, like I said, you could always take, if you don't like this way, you could always take the inverse of one of them and see if it matches the other. You could always do that. All right. Now for number seven, um, I'm going to plug in a 1 here. So what I'm going to do, guys, I'm going to choose 1 again. All right, so f of 1, that's this guy right here. All right, equals the 5th root of -1 plus 3. So if I go to my calculator, and then I plug in negative 1 plus 3. Okay. All right. Plug in negative 1 plus 3. That gives me an ugly decimal number. Okay. All right. Now, guys, if you've got the TI-84, now what I would not do is try to type all these numbers in. You can store that as an X value and plug it in. So let me show you how to do that. So if you got this big old long decimal like this and you don't want to type it back in, this is what you can do. On a TI-84, there is a button here called STO with the arrow pointing to the right. It's up above the on button. It's this guy right here. If you store that, if you hit that button and you store as X and press enter, now X represents this big old long number. Okay? That way you ain't got to type the whole thing in. If I type in X, this number is going to pop into where I put the X. All right? So now, math. All right, and then so on the top, I'm going to do negative X. Now remember, guys, when I store I store that big number here. I stored that big number here as X. So wherever X is it's got this number stored at. Okay, minus 2 divided by 2. Okay. Now, does that look like the number 1? No. So this is not an inverse. Okay, that's not an inverse. And guys, if you need help with the other 6 and 8, I mean, I can help you. I don't want to give you the answer, but I can help you along the way. All right, guys, the next part is you're going to find the inverse of each function. All right. So, guys, if you remember, the first step was when finding an inverse is you changed your function notation to y equals negative 1 plus 1 half x. Okay. So the first thing you do if you're taking an inverse is you're going to change that g of x or whatever that function notation is. You're going to make it a y because it's easier to work with. Okay. All right. Now, the next step is you just simply switch your variables. All right. All right. Now, step 1, step 2. Now, step 3 is, guys, you're going to get the y by itself again. Okay. The y was by itself here, but once you switch the variables, it's no longer by itself. All right. So you're going to add the 1 half. On right over here. It's going to be x plus 1 half equals. Now, guys, instead of writing this thing 1 half y, what I'm going to do, 1 half y is the same as y divided by 2. Okay? Y divided by 2 and 1 half y is the same exact thing. This and this are the exact same thing. Okay? Now, it's pretty simple. So all I'm going to do, guys, is to get this y by itself, this is being divided, y divided by 2. So I need to multiply that to get the y by itself. I'm going to multiply by my denominator. And that's going to be on both sides. Okay. The second what? Let's see. Oh, I did, didn't I? My fault. You talking about here? Okay. Guys, that was my fault. Okay, so if I change that to 1 and 1, that'll make it a little bit easier too. All right. Thank you, guys. So 1. Now, so guys, what's going to happen is this: 2x plus 2 equals y. Okay. Okay. Now, last but not least, all you're going to do, guys, is change this back to g of inverse of x. So g inverse of x equals 2x plus. And guys, another thing too, if I'll send it on its way, Kate. Thank you. One thing about it too, guys, you can always remember the line that it always reflects over is y equals x. So that's the line that all inverses reflects over. So what you can do is leave the y equals x there, okay, and then put your other two functions in. So this is a very quick way of checking it. All right, and then 2x plus 2. Now, guys, as you can tell, this is one function here. That's the other function there. Those do reflect over that line. If you think about it, what I mean is if I take one side of that line and flip it over y equals x, which is this diagonal line here, if I fold it over that line, they're going to fold onto each other. Okay. That being said, if it has that property, you know you got the right inverse. All right. Does everybody remember that? This is a good way to test it. Okay. All right. Now the next one. F of x equals 3x plus 4. Trying to find the inverse. So I'm going to change that to y. So first step, I'm going to change that to a 3x plus 4. Y equals 3x plus 4. And then I'm going to switch my variables. Okay. Okay, so now, guys, what I need to do is get the y by itself again. Okay, so I'm going to subtract 4 from both sides. That's x minus 4 equals 3y. Those cancel. And then, last but not least, I'm going to divide by 3. That's y equals x minus 4 divided by 3. All right, and then last but not least, you're going to have f inverse of x equals x minus 4 over 3. Guys, another way to write that, it would be this f inverse of x. Just in case you would see it on a test and it might be looking different, it'd be 1/3 x minus 4/3. Because when you have a single denominator with an expression, that means that's the denominator of this term and the denominator of that. Okay, so it may be looking. You may see it like this. That just means both of those terms have the same denominator. Is anybody attempted the module? Was it module 2 test? How you do all right with it? Okay. You should have. Did you try both attempts? Okay, you should have another attempt on there. All right. All right. So guys, the last part of it would be piecewise. Um, all right, guys. Remember, that's the same as y. Okay, f of x is the same as y. These are your functions. Okay, these are your functions, and this is your domain. Okay, basically, guys, this is what you graph. These three things. This is where you graph them. Okay, this is the x intervals in which you graph each function. Okay, so now, so the first piece of our piecewise is the absolute value of x minus 1, and we have to do it on the interval of x values less than -1. Okay, so now, so guys, Desmos is a good bit easier. The only reason I don't use it as much because it's hard to get everything on the screen. Um, so if I go to y equals, all right, and then it's absolute value. If I graph that, all right, now guys, all I care about. Notice the only part I care about where it graphs is when x is less than -1. Okay, so guys, remember less than is this way, greater than is to the right. Okay, so guys, all you care about is graphing left of -1. Okay, so now I'm gonna go to my table. All right, so it says when x is -1, y is 0. And guys, remember, if you have a greater than or less than without the equal to, the dot's going to be open. If you've got one that's greater than equal to or less than equal to, notice the only thing difference to equal to, it's going to be a solid colored in dot. Okay, so now on this particular one at -1, 0, that's going to be an open circle. All right, so it's going to be open circle at -1, 0. And guys, I got that off my table here. Okay, so the next one is -2, 1, -3, 2, -4, 3. Oh my gosh, she's about to drive me crazy. I think everybody's here. All right. So that would be that part of our piece. And guys, it tells us, and like I said, how we know where to graph is by our domain. Remember, this is where you graph. Okay. All right. Now, your next piece is y equals x. All right. So y equals x, and you're going to graph that from -1 to +3. Okay. And you're going to do everything in between there. So go back here, clear it out. All right, so we need to find -1 in our table because we know that's where it's going to start. Okay, and -1, this particular -1, -1, -1, -1, is going to be a solid dot because of this, because it's got the equal to. Okay, so it is going to be solid based on having the equal to sign. All right, now if you go to your table, plot some dots. All right, there's that piece. And guys, notice both of them had equal. It was equal to, so you had a solid dot on each side. Okay. All right, guys. So my next piece is x minus 4 squared, which is a quadratic. If I go to my table, and guys, all I care about are x values greater than 3. Okay, that's all I care about. So, guys, remember, greater than is this way. It's going to be going to the right. So I'm going to go find this number in the x column, which it says it's 3, 1. Okay, so 3, 1. How do I know it's an open circle? How do I know this one's an open circle? Good. Good, my guys. So it's not equal to, right? So 3 1 4 0 5 1 and 6 4. I don't think we'll be able to get another one on there. So it's pretty close to it. All right. So that's your pieces, guys. Now, um, it says sketch in your directions, guys. It says sketch the graph of each function. Okay, and then you're going to evaluate each function when an x value is -3, 0, and 5. Okay, so now, all right, guys. So when x is -3,
Sorry for the interruption. Any students that want lunch today, please enter it now. If you ordered earlier, please go ahead and resubmit your order. It did not take. Please enter your order now for lunch. Thank you.
all right, guys. So it says when x is -3. So if I find -3 on the x-axis, I go up to where the function is. This function crosses at +2. So that being said, when x is -3, y is +2. Guys, you can also find it in your table. It's in this domain, right? Because negative 3 is less than negative 1, you can plug it in here. And then negative 3, the absolute value of negative 3 is 3 minus 1 will be 2. You could also do it that way. Now, looking at my graph, guys, when x is 0, it looks like to me that y is 0 as well. So when f of 0 equals 0. Or once again, guys, 0 is between this interval. So you just plug in 0 for x. Well, if 0 is x is 0, then y is going to be 0 as well. All right. When x is 5, well, guys, here's when x is 5. What y value would that correspond with that point right here? What's the y value? What coordinate point is that? We know it's 5. That is 5, 1. Okay. So that being said, when x is 5, the y value is 1. So guys, make sure you do both of those parts, okay? All right, guys, we've done enough to get you started pretty much on the whole paper. I'm going to stop for right now because I've been talking a little bit too long. But go ahead and work on these. If you need a little bit of help to get through, just let me know. I can help you. But then we may come back and do number 15 in a little while, okay? All right, let me pause this.